So let's take a look at what's really happening inside this engine. What you're seeing right now is a 3D cutaway of an internal combustion engine, specifically focused on the transmission section. The parts highlighted in blue are the key gears that transfer power, and those yellow arrows are showing us exactly which way everything rotates. It all starts with a tiny explosion. Inside the combustion chamber, a precise mixture of air and fuel is compressed by the piston and then ignited by the spark plug. That explosion creates a massive force that shoves the piston straight down. You can see that up and down motion clearly in the animation. But a piston moving in a straight line isn't enough to turn a wheel, so it's connected to a crankshaft through a connecting rod. Think of it like the pedals on a bicycle. Your legs push down, but that motion gets converted into the rotation of the chainring. Same idea here. As the piston is forced down, it makes the crankshaft spin. That's the first critical conversion we need, changing linear motion into rotational motion. Now that we have a spinning crankshaft, we have usable power, but we can't send it straight to the wheel. Why not? Because an engine doesn't make the same power at all speeds. Sometimes you need a lot of torque to start moving or climb a hill, and other times you need high speed for the highway. This is where the transmission comes in. The blue gears you see are the heart of this gearbox. The first gear connected to the crankshaft is called the primary drive. It sends power through the clutch to a set of gears on a different shaft. Look closely at the yellow arrows. When a small gear is driving a much larger gear, like what happens in first gear, the output spins slower but with a lot more twisting force, or torque. That's exactly what you need to get a heavy motorcycle moving from a complete stop. This is why first gear feels so powerful but you can't go very fast in it. So what happens when you shift? Inside the transmission, there are several pairs of gears, but only one pair is actually locked together at any given time. When you click up into second gear, a component called a shifter fork slides one of these blue gears sideways along its shaft. In the animation, you can see that sliding motion. It disconnects from the first gear pair and locks into a different pair. The new gear ratio is different. In second gear, the driving gear is a little bigger, so the output shaft spins faster than it did in first, but with slightly less torque. This pattern continues as you go up through third, fourth, and fifth gear. Each higher gear gives you more speed and less torque, letting the engine stay in its most efficient RPM range while the bike goes faster and faster. Once the power has been modified by the transmission, it has to get to the rear wheel. It travels up through the output shaft. On the right side of the animation, you can see a small sprocket attached to the shaft. This is where the chain goes. The chain then wraps around a much larger sprocket on the rear wheel. This is another gear ratio, called the final drive ratio. If the rear sprocket is very large, like on a dirt bike, you get tons of torque for climbing. On a sport bike, the ratio is set up to give you a higher top speed. With all these metal parts spinning and sliding against each other at thousands of RPM, friction and heat would destroy them in seconds. That's why engine oil is so important. It's constantly pumped to every gear and bearing, creating a thin film that lets everything slide smoothly. The metallic shine you see on these parts in the animation is thanks to that oil protecting them. So, from the initial explosion that drives the piston down, to the crankshaft that converts it into rotation, through the sliding blue gears of the transmission that select the right amount of speed and torque, and finally out through the chain to the rear wheel, every single component has a job. It's a perfect chain of events happening hundreds of times every second. The next time you twist the throttle, you'll know exactly what kind of mechanical symphony is playing now right beneath you.